Login accepted.
Uh, okay, there's the recording. Awesome. It still looks good to y'all, right? Hope so. Sign in link if you haven't seen it. If someone wants to copy and paste this in the chat, go for it. Leave it here for like 10 more seconds. I lied, 5 seconds. All right, who am I? I'm Dylan. My handle online is Nigerald. If you see me, you can call me Dylan or Nigel. I think Nigel's funnier, and I've been introducing myself as that to some people. Majoring CIS, graduating 2025, currently doing adversary services at my internship at IBM's Express Red Team. I was the Linux guy for CCDC between 2021 and 2024, or for the latter half of that, I was the, like, I guess the de facto Linux lead. And for CPTC, I primarily did Windows. My second year, I was the captain for my third year. My first year, I was just kind of doing whatever the hell people wanted to throw at me. I'm mostly a Windows person, really like Windows, from everything that we're going to cover today down to the more lower level stuff. So I don't know why I ended up doing Linux and CCDC, but whatever. So schedule, we are getting very close to tryouts. So congratulations on making it so far. This far so far. If you're here, let's see. I mean, it's tough. Well aware of that. I went through it myself, but it was, yeah, I mean, even then at the time it was really hard, but it still wasn't, it wasn't as hard as it is now. It gets harder all the time, but that's part of the fun of it. So for today's agenda, we'll be covering some basic stuff about Windows, then we'll be talking about common services, then we're gonna move into attacking Active Directory, since really that's primarily Windows's attack surface. It's not Windows itself, it's the platform it's integrated in, which is typically Active Directory, and then we'll go into the homework. So there are various different attacks on Windows that you can do as on the system itself, sort of like how last week when we were covering Linux, we were saying, okay, well, these are specific attacks that are pertinent to the Linux operating system. There are certain functionalities that you can abuse built in, and this is the same with Windows. There's a good chunk of them. We won't be covering all of them. And then, this, I mean, you don't really have a point of reference, but I mean, to me, this doesn't look too bad, because when you look at what it turns into when you combine, when you bring in Active Directory, it's like, okay, all of a sudden you have all of this extra attack surface, all these different things that can be abused. And this is all on top of effectively the previous slide. And this is by no means an exhaustive list. I literally came up with all these like on the top of my head in like 2 minutes. I was like, oh, what can you do on Windows? Started typing things. I was like, oh, that's a lot. So yeah, fun stuff though. So let's cover some basics. And by the way, I will be talking about what Active Directory is in a bit. I'm aware that some of you may not be aware what it is, and I'm just spitting words right now. But that's what a lot of this today's meeting is going to be. It's going to be a lot of words, a lot of terminology and stuff that you probably won't remember. So the recording is going to be really helpful, or at least I'd hope so. So the file system, similar to Linux, but instead of forward slashes, you have backslashes. The file system root is usually the C root. By default, it's the C drive. You can customize it, you can change it, you can add additional drives, and then in that sense, you have like multiple file systems almost. Nothing too complicated here. Main difference, I would say, aside from the slash, is Windows is case insensitive. So yeah, as you see down here, exe is the same as null caps. Windows credentials, I'm not sure if I do not recall if Linux credentials were covered. And over here, there's a bunch of words. You don't need to pay attention to all of this. This is honestly more of a goofy slide, because it really tells you how stupid some stuff in Windows is. So originally, Windows credentials, you had the LM hash, which is an old hashing algorithm that Windows used and realized, wow, this sucks. TLDR, it sucked cryptographically. Your passwords were effectively case insensitive and a maximum of like 7 letters. Anything or 14 letters. Anything after that didn't matter. So yeah, that was weird. So they made the NT hash, which is what they still use now. A little better, for whatever reason. I'm no crypto person. So these two are often put together in what is called the NTLM hash, which is, of course, the LM and then the NT hash, because NTLM is LMNT. Yeah, cool stuff. NTLM is the what people will primarily be referring to when talking about Windows authentication. They call it NTLM authentication. It's effectively authentication through the usage of the NT hash. LM is primarily deprecated, and you will hardly ever see it on systems. Very rare. I don't know why they don't just call it NT authentication. It's NTLM authentication. When you're authenticating over the network, it's going to be called net NTLM, which means NTLM over the network. There's two versions. Version 1 sucks. Version 2 is the default, and it's not too much better. In fact, NTLM authentication sucks in general, but it's just how Windows works. Then you have these sort of 3 credential stores. Well, 4, I just forgot to put it here. You have SAM, the security account manager. You're gonna have local credentials in here. What this means is accounts that are on a machine, right? Like your personal computer. That is where credentials are. They're storing this thing called SAM. It's available, accessible in the registry, and there's a file somewhere, if I'm not mistaken. Then you have and there are like there's some encryption and stuff going on, but it's possible to circumvent those. Then you have LSA, the local security authority. This is basically saying, hey, we store secrets. It's just a different set of creds, like how Sam's like, okay, I store local creds. LSA is like, I store other creds, such as service credentials. It says scheduled task here. That is wrong. Ignore that, please. I'm actually gonna fix that right now. Yeah, so LSA is going to store service account credentials. So in Linux, I believe y'all went over services. In Windows, you also have services they can run as an account. And when you make it run as an account, you can provide it credentials that it's stored in LSA. And in LSAS, it is a process that runs on your computer. It just caches credentials in memory. So if you can dump that, you can extract credentials. We'll go into all of this more in depth later. This is just sort of point of reference. There's another reference slide. This is the NTLM authentication that I was talking about. It is at a basic level, it's a sort of challenge response authentication. You basically say, hey, step 1 over here. Get my pointer on. Step 1's like, hey, I want to authenticate as this person, right? Then the server that you're authenticating to is going to send you back a challenge. They're basically going to send you some sort of data. And the expectation is, if you are truly that account, you are going to have the correct credentials to that account, right? So like if I'm Bill, I should have Bill's password, right? So I say, hey, I want to authenticate as Bill. They're like, okay, here's some random data. I want you to encrypt it with Bill's password, effectively, right? And so you're going to go ahead and encrypt that according to whatever cryptographic scheme it's supposed to be, and it gets sent back to the server, and the server just double checks and says, hey, that looks right. And yeah, that's really how it's really similar to saying, hey, I'm this person, here's my password, and they're like, oh yeah, good to go, except little extra steps. I don't know why I have this slide if I already covered these, so we're just gonna move on. This is the one I forgot to bring up. DP API, too many syllables, so I call it DPOPI. Stands for Data Protection API, and it is Windows' solution to, wow, cryptography is hard. Wouldn't it be really easy if we had some sort of built-in solution to encrypt stuff that the developer didn't need to think about? They just say, oh, I do the thing and it is encrypted and we are good. the way the encryption actually works is it is derived from some user and system information that gets credential information gets put into involved with the encryption process. So basically, it is reversible if we have a high enough privilege or if we're in the right context. We'll go into that later. And these multiple places that DP API is used, schedule tasks, right? Just like how you have services run as a specific account on Windows, you can have a scheduled task run as a specific account. So maybe it's like, hey, I want some random account I made to run a PowerShell script every minute. You're gonna have to provide those credentials, and they get stored by DP API. Then you also have your browser passwords. Best what you call it, security practice is to use password manager, but a lot of people will just say like type your credentials and you hit like, oh, it says, oh, would you like to save it? And you save it. That those credentials are stored and secured by DP API. Yeah, so like, these are your credential guys. I don't remember why I made this. We can finally move into Active Directory after covering all those random credential stuff and some basic Windows stuff. Active Directory is sort of like what makes Windows Windows. I think it's a bit rare to see Windows without Active Directory in any sort of production environment. Active Directory runs off of a series of different protocols that we'll be covering in a bit. But you can think of it almost like it's a platform to essentially manage a whole lot of resources. And I mean, yeah, that's honestly what it really is. So like if you have hundreds of users in your company, you have hundreds of well, honestly, hundreds is small. These things go up to tens of thousands. Tens of thousands users, tens of thousands computers, other devices, maybe like printers, right? You have file shares and other servers running. You gotta figure out a way to both manage them. So like, okay, how can I configure them? You need to figure out, okay, like remote access, because you're not going to manually provision each machine. That's not scalable. That's not feasible at all. And then you also need to like figure out like how can you delegate control over specific parts of your company's resources to specific individuals, right? Active Directory takes care of all that. It provides functionality to do so. You have a variety of things like group policies, organizational units, users and groups that you can use that you can all combine to basically manage all this. So hopefully that was a bit clear. It's really hard to explain Active Directory, but when you start testing it, you sort of start getting a general feel for it and understanding like, okay, this is sort of what it is. Because it's really just a platform to do something. It's how I usually like to imagine it. But anyways, common services and interacting with them. Common services running on Windows themselves. Honestly, SMB is going to be the most common thing, and that runs on port 445 TCP. And you're going to have remote desktop. This one's not default, but it's still somewhat common because people use it to remote into computers and just like access them remotely with a UI component. SMB port 445. It is, you could use it to share files, and that's what a lot of it is used for. So when people say like Windows file shares, they're typically going to be SMB. They can be FTP, but majority of the time it is SMB. It's the sort of built-in thing. Allows you just to basically share a folder over the network. There's multiple, when you authenticate to it, you authenticate using your Windows account, but sometimes for Windows, you can also have like a null or a guest authentication, which means you can sort of access shares unauthenticated. The other part about SMB and the weird part about SMB is it's also like this sort of cursed black magic that runs and does a lot of things for Windows in the background. So if you have admin access to a computer and you have network access to SMB, the file share, you can run commands on the computer. It's really funny. Windows is Windows has a lot of weird things going on like that. And Yeah. I mean, there's reasons behind it, but that's out of the scope of this presentation. Then you have RDP. If if you're a part of a group member, if you're a member of a group, the user that you control, and it has that group is the remote desktop users or a child of that group, you can just remotely access the desktop. I mean, it's just kind of how it works. And we're going to be moving into the common Active Directory services. So well, we call them Active Directory servers, but they're really primarily services that run on the domain controller, which is this central server that effectively controls the domain being a sort of uh the best way to put it is like the domain is the active. I can't think of a good way to put this. That's tough. That's rough. It's just sort of central management of our, not central management, but unit of organization of all the resources. So within a domain, you're going to have all your other stuff within it. So you're going to put your computers into the domain, your organizational units and whatnot. It's just another like higher level of abstraction between all that. So these ports are going to be primarily seen on the domain controller minus WinRM. WinRM can run on any Windows hosts. You're going to have DNS, Kerberos, LDAP. DNS, Active Directory completely runs off of DNS. Everything refers to each other by name. Without DNS, everything starts sort of breaking. Kerberos is another authentication protocol that you have within Active Directory. So Active Directory works with NTLM and Kerberos. Kerberos being the one that's more secure, but there's still a lot of things that you can do with it. Then you have LDAP, which is the lightweight directory access protocol. I like to describe it as a language of Active Directory. More on that in a bit. And WinRM is another remoting protocol, except rather than having a UI access, you're going to have not, well, more like you can remotely access a machine through the CLI effectively. It's almost like an SSH for Windows, but it doesn't use the SSH protocol. So we'll be starting off with Kerberos. This one always gets people because it looks confusing and it's a lot. I like to break it down into 3 sort of steps. So, I mean, there's 6 steps in this chart, but you can sort of categorize them as 2 steps, or 3 steps with each being 2. So step 1 and step 2 is called the ASREC and the ASREP. Full name being authentication server request and authentication server reply. That's over here. I like to call these this is like the first step of the authentication, because this is when you basically say, hey, I want to authenticate as a particular user, and then it's at this point in time where the KDC or the key distribution center, which is just going to be the domain controller 99% of the time, it's going to respond with well, it's going to verify your identity and effectively give you an approval. Now, whereas NTLM, it's just you either authenticate or you don't. Kerberos works through a system of tickets, TGTs and service tickets. TGTs being ticket granting tickets. The difference between these two is the ticket granting ticket grants service tickets. That's why it's called ticket granting ticket. Service tickets are tickets that you use to authenticate to services that work with the Kerberos protocol. This first 2 steps, right, the ASREC and the ASREP, they're the authentication. And when you're authenticating to get a, well, initially when you're authenticating to get a TGT. So if you're able to provide the proper information for these first 2 steps, you're going to end up having the TGT. And then you're going to move into these next 2 steps where you use your TGT to effectively just get the service ticket that you want. Now, This chart's actually wrong. It says KRB TGT rec. It's supposed to be TGS rec and TGS rep. I didn't notice that until now. But this step, the steps 3 and 4, or the second part of the authentication, is basically now that we have our TGT from step 1 from properly authenticating with our Windows credentials, we're going to use that ticket to request a service ticket. If a service supports Kerberos authentication, it has what's called a service principal name. So let's just say you have Microsoft SQL or MS SQL. MS SQL is going to have a service principal name, which means that you can request a service ticket for that service principal name, right? So using our TGT, we request a service ticket for a particular SPN, or just you could shorten it to, we use our TGT to request a service ticket for a service. And then you have the last steps, the AP rec and the AP rep. And over here, this is where we use the service ticket that we obtained, and we say, hey, want access to some sort of service, or in this case, they call it the application server. Does that make sense so far? Does anyone have any questions about anything that I've been covering? No questions is always a great thing. That means everyone's 100% following along. So coming up next, we're going to move into LDAP, or as I was saying, the language of Active Directory. It follows this syntax of identifiers. On the bottom, you see CN, JDO, OU people, DC example, DC com. You could think of LDAP almost like a file system through these identifiers, with the ones on the far right being the sort of root of it, right? So typically these DCs are going to be like your domain. So in this case, this object would be within the people organization. So that sort of trying to read this LDAP, what they call a distinguished name. This would mean that the user JDO is a part of the the organizational group unit called people, and it's a part of the domain example.com. The reason why I call this a language of Active Directory is like in Active Directory, everything's an object, as I was saying. To control all your assets, Active Directory in this case uses LDAP. And so all your resources become LDAP objects, right? All of your users, so your employees, right? All of your servers, all your machines are all objects on LDAP. And they all have sort of different identifiers and different classifications, right? So users will be users. Usually there's like some sort of users organizational unit within the domain. Machines will have a machine account, which is in like the machines OU of the domain. And everything's sort of identified this way. There's I don't really use LDAP search too often. I just want to include this as a reference. Like this is some way that you can search through LDAP. There you could search up a lot of different ways, but you won't be making manual queries a lot, at least within CPTC slash this trial. That's a bit excessive. And we have WinRM, the Windows Remote Management. If you have credentials and that the user they have credentials with has the WinRM is a part of the group that is allowed to authenticate, or there's a WinRM group on Windows, and if your user is a part of that group, you can WinRM into a computer. There's a tool to utilize this protocol to give you like a sort of shell access called Evil WinRM, which is what I have shown down below. But usually this is like the normal use of it is like what's called like PowerShell remoting, where you remotely access computers through PowerShell, and under the hood that ends up using WinRM. Now that we covered the services and some basics about how Windows credentials and authentication works, we can start moving into talking about like how do you actually operate and attack Active Directory. The reason why we're talking about attacking Active Directory and rather than attacking Windows is because, well, Active Directory has Windows in it, and you'll hardly see Windows without Active Directory. And Active Directory provides such a different attack surface and different methodology than just attacking Windows. Honestly, attacking Windows is really similar to what you were already doing last week with attacking Linux. You just find some services that are running on it. You look what ports are open, and you kind of just do your thing. Attacking Active Directory is a lot different once you get in. It's not so much, okay, like how can I escalate on this system? What's like weird misconfiguration on the system? You don't think of Active Directory as a single system, but as a collective. Which is so we're gonna more focus on that side of things. Plus, it's that's usually the skill people are looking for and talk about rather than saying, do you know how to break a Windows system? So the whole methodology with Active Directory, as I was saying, is, well, keeping it short, it's about context. You want to think, where are you within the active, within whatever company's Active Directory unit, right? So like, who are you? What can you do? Remember, in LDAP, everything's an object. These objects, and we'll cover this later, is they have relationships between each other. You can abuse these relationships or to what you call like take over other objects or compromise other objects, right? I don't know if we covered lateral movement yet, but lateral movement is like moving from one machine to another. This is similar, but not really. You're more like compromising one object on the domain to another object. The reason why you want to do that is if you know what that other object can do, you would want and you can compromise it, then depending on whether or not it can do something useful, and that's something that you want, that's the approach that you want to take. So if I'm a basic user and I'm able to somehow, for whatever reason, compromise an administrative account, and then by compromising them, I'm able to authenticate and perform actions within Active Directory under their context, that would effectively mean I just compromise the whole Active Directory domain. Here's a much longer methodology that I do not really want to cover as much, but you basically try to find a way in. And once you find your way in, you do what I was talking about before, where you try to figure out your context and you work around that. So we're gonna starting off with initial access in Active Directory. You have version exploits. There are a lot of them because Windows keeps having funny issues. Now, version exploits that affect Windows also affect Active Directory because Active Directory runs on Windows, right? So Eternal Blue isn't necessarily a Active Directory specific vulnerability. It was a Windows or exploit. It was a Windows exploit, but because Active Directory runs on Windows, Active Directory was heavily impacted by this. And then you have zero logon. This one, zero logon, is actually, to my awareness, an Active Directory specific vulnerability. You have some others that won't be covered for the sake of time, but they're pretty notable. So Eternal Blue, basically, if you hit a outdated system that's running SMB version 1, you can immediately get system access. And for reference, system access is above administrator. Administrator being like the equivalent of root on Linux. System, you could think of system access as the machine itself, right? And all you really need to do this is just network access and SMB version 1. You sometimes need credentials and you sometimes don't. It's and this is just from my experience from attacking or using this exploit, but sometimes it works and without credentials and sometimes it doesn't. Does Linux have the equivalent of a system access? I did not to my awareness, but I mean, people usually say that an admin on Windows is the same as root on Linux, but I feel like root is more powerful on Linux than admin sort of is on Windows. But that that would be getting to like very specific and what you call it. It's a pedantic stuff like it's a feature, not a vuln type of thing. So I can't really make that argument, but keeping it short, I do not think Linux has an equivalent of system access. So yeah, Eternal Blue, funny exploit. I think this one got used to deploy a ton of ransomware, which was interesting back in 2017 when I was in high school. So I think even I heard I didn't hear about Eternal Blue. I just heard, wow, ransomware was happening. Then you have Zero Logon. This one was a very bad vulnerability for Windows or Active Directory because domain control, there was a cryptographic flaw within the one of the authentication protocols. I know I covered uh Kerberos and NTLM authentication. There's some more random extra stuff. There was a specific protocol that when you authenticated into it, there was some cryptographic flaws that resulted you in effectively being able to authenticate as any machine account in the domain, including the domain controller, without actually providing any credential. You had like a 1 in 256 chance to do this, and there was just no lockout policy. Like that was not a thing for this protocol. So by just having network access to the domain controller, you could wait a bit and all of a sudden authenticate as the domain controller. And as we'll show you in a bit, this had meant a lot of bad things because the domain controllers, they control the domain, they control the authentication flow, um they literally manage the domain. If you compromise the domain controllers, it's just over. And that's how it was for a lot of people. I'm not gonna demo any of those initial accesses stuff because there's a Active Directory. You have like this when it comes to initial access, it's sort of a little narrow. There's not too many things you could do. What initial access really means in Active Directory is it's not necessarily you got a shell like in Linux. It's more so you have a presence in the domain. Having a shell definitely counts as that, right? But also just having a user account, right? If you have a user account in the domain, that also counts as having a foothold because Active Directory doesn't necessarily work in terms of machines. It really works in LDAP, right? You can authenticate and you are an object that is understood by Active Directory. You can do things to the domain, right? Uh, so there's a lot more privilege escalation on just post exploitation related things. In fact, when you're doing an Active Directory test, a lot of the times you'll be provisioned an account or some sort of adjacent network level access that would like initial access isn't as much of a concern in the traditional ways. So the first this is like the first thing that you probably want to do once you have some sort of context or once you establish your foothold in Active Directory is you want to use a tool called Bloodhound. I think Bloodhound is like a dog that's good at sniffing things, which is where the name of the tool came from, right? Basically, as long as you have network level access to the domain controller and you have some sort of context, so you either have valid credentials or you have a shell on a system that you exploited and that shell is running as a domain user or include or a system which counts as a domain user within Active Directory, you can get a lot of information. You could see different attack paths. That whole thing I was talking about figuring out your context within Active Directory, Bloodhound allows you to get all that information and visualize it immediately. So for example, in this small picture, you could see there's a few accounts on this HTTP local domain, and we could see, as I was saying in earlier, LDAP things have relationships with each other, right? And Bloodhound is going to allow you to visualize that and literally tell you what these things are. So this MRLKY user on the domain has a privilege on the domain object itself, which is just the domain called get changes all. I'm going to do a little demo of Bloodhound. So I've already installed Bloodhound on this machine. But so all we're gonna need to do is it runs with a backend database called Neo4j. So we're just gonna run Neo4j console. And I left Bloodhound in the op directory. So we're gonna do op Bloodhound. I'm running it as root. Bad idea, probably. I don't really care. So I'm gonna have to pass a no sandbox flag because it is running as Electron. It is an Electron application to my awareness. Password that I set up is the username is Neo4j, the password's bruh. This is the old version of Bloodhound. There's a new version. I prefer the old version. For labs. The new version is much faster, but there are certain functionalities and things that they switched up that I haven't really gotten too used to, and I have a bit of complaints about. So for lab purposes, we're sticking to this one. Now we're gonna move into Kerberos attacks. There are a ton of them. We're gonna focus on the shorter and simpler ones based on the understanding the protocol that I brought up a little earlier, because the other ones they are much more advanced. So we have the AS rep roast attack. So I feel like I said this a million times now, but in Active Directory, in it speaks with LDAP. LDAP, everything's an object. These objects have attributes. So if there's a user account object with a don't require pre-auth flag, you can effectively do those. If I don't know if I have the diagram over here, but okay, yeah, that's useful. This first two steps of Kerberos authentication, you get a bit of you sort of get to skip through step one. That is the ASREC, because you do not require pre-auth, so you don't need to do your pre-authentication, which just means you don't need to authenticate to get a TGT. Now, for certain reasons, this TGT won't actually be usable by you won't be able to use the TGT, but that's not the point of this attack. The point is we are going to be able to get a hash out of this, and we can crack this hash to get the password for the user that was configured this way. All this is going to require is network level access to the domain controller, because to talk to we need to talk to Kerberos, and Kerberos runs on the domain controller. From there, if we have a username, we can just try to perform authentication. If it gives us an access denied, you say, oh, okay, we didn't have a password. But if it just gives us a valid response, then we know, oh, the account did not require pre-authentication. There's a command to run it on the bottom that says curb roasting, not ASREP roasting. That's a typo. Probably should fix that. Okay. So like I said, the first two steps of Kerberos authentication, where you get your TGT that you will later use to get service tickets, it requires the first authentication step being the ASREC. If we have don't require pre-auth on the user we're trying to authenticate with, we get to skip this first step and we immediately get our KRB ASREP. What this ASREP looks like is you have the whole message, and you have part of it has the TGT, because this is step one, or this is the first part of Kerberos authentication that involves obtaining the TGT. It is, and you're also going to have a part of the ASREP message that is encrypted with a hash of the user. Using this encrypted information, I'm not huge on crypto, and keeping brief, using this encrypted information, we're able to sort of derive the session key out of this, and or at least we can try to brute force or crack the session key out of this. And if we're able to, in turn, that means we have also been able to grab the password of the user. The second attack we're doing is called the curb roast. It is really similar to the ASREP roast, except rather than attacking the first two steps of authentication, we're attacking the next two steps of authentication. ASREP roasting is much less common than curb roasting. Curb roasting is a feature, not a vulnerability, or a feature, not a misconfiguration. ASREP roasting is straight up a misconfiguration. This flag is not default; it has to be put on something. And generally there's no reason to. There's some compatibility stuff, but I haven't ever seen that in practice. Kerberoasting, however, does not require really anything. Anything that has a service principal name, in other words, anything that is a service, can be Kerberoasted. Oh, how should I say? Anything that's a Kerberos service or supports Kerberos authentication can be Kerberoasted, which is fun. uh, just like ASREP roasting, all you need for this is network access, except you're also going to need credentials. And the reason why we need credentials is first, we're doing steps 3 and 4 here. Steps 3 and 4 involve requesting a service ticket using the TGT. We're going to need to authenticate first to get a TGT, which is why we need credentials. The TGT, remember, it comes from step 1 and 2. The TGT, we can then request a service ticket and perform this attack. The actual attack is happening in the normal TGS response from the Kerberos authentication when you're requesting a service ticket, because the service ticket is encrypted with the password hash of the account that is associated with the service. So when you create some sort of application that supports Kerberos authentication, it usually in Active Directory, it's going to need an associate account with a service principal name, and that's effectively that service's context within Active Directory, right? So the password of that account is used to encrypt the service ticket, part of the response. So just like with ASREP roasting, we're able to use this bit of encrypted data to try to brute force and extract a session key. And in doing so, we end up getting the password of service account. We're gonna go demo this attack. I don't have a demo for ASREP roasting, but it's just like a 1 flag difference. So that's not really too important here. So and by the way, this is in a bit of like an assumed breach situation almost. In that, like I said, we're gonna need credentials. For the sake of this demo, I have credentials. So we're gonna run the tool netexec. Netexec, for reference, is a sort of Swiss Army knife of Active Directory testing. There are a bunch of before a lot of things were like PowerShell based, but testers like we want to be able to run things remotely and do from our Kali machines or whatever. We want to be able to hit a bunch of systems. So people started making Python tooling, and there was a library called Impacket that was sort of the core of it. Impacket has a series of scripts that interact with Active Directory, and they have example scripts to perform specific attacks. And then netexec, originally crackmapexec, was is a tool that basically got all their implementations and made a giant wrapper around them. So you don't need to remember 20, 30 different scripts, and you just use the tool and pass certain arguments, and it just works. Until it doesn't, then you cry. And it doesn't work like a good amount of time, but for the most part, it works. So before I do this, one thing that I did talk about earlier is Active Directory runs on not just on LDAP, but on DNS. Everything talks to each other by name. And this is going to be really important. Whenever you're doing any sort of Active Directory test, you're going to want to make sure that your DNS is pointed towards the domain controller, because the domain controller also runs DNS, and you want to be able to resolve names like it does. So in this case, I already have the IP of the domain controller. First thing we usually want to do in Active Directory, when we know we're dealing with an Active Directory environment, is we want to find out where are the Windows machines and where our domain controller is. And in doing so, we can finally perform our attacks, such as Kerberoasting. So first, we're just going to run netexec with the SMB protocol on this 24. That's the scope for this lab. And we can see it's trying to hit 256 targets because that's outsider, and 3 machines. Who wants to take a guess which one's the domain controller? All right, I just want a water break. You didn't actually have to answer that. Yeah, it's the second one. 182, 168, 15. names in Active Directory are 2016. Yeah, I mean it is it's not because SMBV1 is true. I was just going honestly, I was just going off the name. I'm just like that like people can clearly change the name. Yes, they can. The name you don't need to name your domain controller DC, but it is it's at this point like it's a standard. It's like an unofficial stand for people to sort of name things in a certain way that indicates their role on the domain. Now, sometimes it's a bit context dependent depending on the company. Like if you have an international company and you have workstations in like Japan and workstations in Europe, you might have like little abbreviations. But at the end of the day, these names contain a lot of contextual clue to their role in the network. They don't necessarily need to be understandable by us, but they do play a role. And oftentimes you will see domain controllers with the name DC. You guess because data center. Uh, the yeah, I guess I could see that. I don't know why this one says like Windows Server 22 versus data center. Yeah, to my awareness, there's a Windows Server 22 data center, but domain controllers will also only run on Windows Server. So you could have a Windows server that isn't a domain controller, but if you have a domain controller, it is a Windows server. If there's multiple DCs, that's a great question. And this is actually something I did with a test last year, right? So the reason why you have multiple DCs is, all right, if your whole domain or your whole Active Directory infrastructure is running off of a domain controller, which centralizes authentication and whatnot between everything going on the domain. It runs the LDAP. It's how machines know each other. It runs DNS, so machines know each other. It runs LDAP, so things can interact properly, right? But if that DC goes down, it's kind of over, right? Like, what if power outage, disk corruption, gone, GG, right? So many companies will have multiple domain controllers, right? For redundancy. Each of the there's also something called a read-only domain controller, but that's out of context, out of scope of this. You'll have multiple domain controllers for redundancy. So it's like, okay, one domain controller dies, but we have another one up, so it can still act and do perform functionality so our domain doesn't explode. The the ability for the secondary or third or fourth or whatever domain controller do this is through a process called replication. We'll go a bit into how replication works and how we can actually abuse replication in a bit. But basically, they sync data between each other. So one goes down, the other one's like, well, I synced and I have all the data. So I can work with that. That's why you would have multiple domain controllers. If there are multiple domain controllers, honestly, you could just talk to any one of them because they have their data synced. The information you'll get and the information that you want. So the information you read from the domain controller, it's synced up with all the other ones. So you'll be reading the proper information. It doesn't change which domain controller you're talking about because they're all synced. Same if you do a write. We'll go into what a write is later. But you could think of a write as, let's say we modified something in LDAP because we had a privilege to do so. You modify on the domain controller, it syncs up with the other ones. So same situation there. So if there's multiple domain controllers, you can talk to anyone. You ideally, if you're dealing with a really large company, you would want to hit the domain controller that's closest to you. Last year, our client was international. They had 100 domain controllers in one domain. We hit one domain and it took like 4 minutes to get a response. I think that domain control was like in France. Then we hit another domain, but that one was actually in the States. So we got like a pretty timely response. We're like, okay, let's use a domain control like 32. It was really called like DC 32, which is what I'm saying, where names are very useful in Active Directory because they provide a lot of contextual information. Imagine being an IT administrator and you can't even tell what your resources are doing, right? Because they're all just named really weird. So having a naming context is also useful from a management perspective, and we can use that against them to understand how their environment works. That was really a long way to answer the question, but there was a lot of important details to come out of that. So does that sort of make sense? All right, awesome. Yeah, going back into it though, by running this, we figured out, okay, DC01, that sounds like domain controller, right? We can double this up with We could also just check for LDAP, for the most part, because the controls run off of LDAP. But SMB is a little easy because it allows us to also see all of the Windows machines that are running in the environment, because Windows runs SMB. Linux is rare, and usually it's a little obvious if it's Linux running SMB and whatnot. Where is this? Yeah, from LDAP scan takes a little longer to run, and it tries to do SMB stuff first. Unless the tool works differently than it used to, it should show up if something is running LDAP, but it might not in this case since I didn't provide it credentials. Whatever, it's taking too long. We know which one's the domain control anyway, so we can actually do the Kerberos attack now. So with the Kerberos attack, we're just going to specify our credentials. In this case, like I said, it's like a bit of a assumed breach. I have the credentials. Right. And we're just going to do Kerberoasting, and we're going to specify an output file. It should say 5. The reason why we're authenticating over LDAP to perform this specific attack, because you're like, hey, Kerberos is port 88. Why are you doing LDAP? And it's because to actually find the Kerberostable account, right? The Kerberosting process does occur over. Actually, I'll throw this question out. Does anyone want to take a guess why we're using LDAP to do Kerberos if Kerberos is a Kerberos attack and Kerberos runs on 88 Kerberos? Or I'm just, for the sake of time, I'm just gonna move on with this. The reason for this is Kerberos attack Kerberosting attacks accounts that have a service principal name. So the service accounts I was talking about, right? Not everything is going to be a service account. You have to figure out which account. Oh, response. Can DC run Kerberos directly? Yeah, the domain controllers do run Kerberos. Like it's just straight up on port 88. If I run an nmap on this thing right now, you should be able to see that. So nmap pn p88 60.5. Yeah, see, we got Kerberos. Yeah. So the reason why we're hitting LDAP first is Kerberosing attack occurs on a service account, an account with a service principal name. Remember, everything's LDAP, right? So this service account is also an account on LDAP. This service principal name is an attribute on LDAP. So the way we figure out if an account is a service account or not is we go through LDAP and we query that information, right? Once we query that information, figure out which accounts have an SPN, we then do our Kerberos authentication with the account we provided, right? This Ichiban guy. And then from there, we then moves into step 3 and 4 of Kerberos authentication, right? We authenticate with Ichiban to get our Ichiban's TGT. Then we request service tickets for the accounts that we queried through LDAP for that we know are service accounts, right? And that way we can actually end up getting this Kerberos response. And then from here, we have this big hash. And it's like, wow, I don't know how to crack hashes. Me there. I don't know how to do math, but I know how to copy and paste hash into hash txt. I have to remove the new lines on this one, and that's going to be painful. Let's see. Hopefully this is left out in my logs somewhere. No, it was not. I'm literally just going to have to remove all the new lines on this thing manually. That's going to be painful. All right, I already messed up. But basically, if you were able to write that into a proper hash file, well, actually, I'm gonna do it. Oh, I'm stupid. I put an output txt. I forgot. I already automatically does it for you. So it's an output txt, right? We don't even need to copy and paste it. And then we can use a tool called hashcat to go through that this hash. It's gonna automatically recognize it and try to crack it. We just need in this case, we're gonna provide it a word list. This word list, this is gonna be a what we call like a dictionary tag. Basically, it's whatever hashing format Hashcat recognizes the Kerberos hash to be. It's going to like sort of like hash all the words in the dictionary, or in the word list we provided, and do a hash comparison to see if they match. So because a hash is like a one-way transformation, so if it matches, then it's well, you found the original string of data, the original data that was there before the hashing was done. I forgot how long it takes to start up. It's a little annoying, but once Hashcat works, it usually doesn't take too long. Oh, and if you could see over here, it says we cracked the hash, and the password is this thing at the end, right after the colon. So that's how you can do a curve roasting attack. Is rep roasting is basically the same, except rather than saying curve roasting as the flag, you do ace rep roasting. Could you also slap into CyberChef? I don't think CyberChef supports that particular hash type that Kerberos or Kerberos' TGS rep is. So that hash that was also output by the tool is like specifically formatted for Hashcat to parse it properly, because there's more data than just the hash itself in that blob of data that is required to perform the decryption. Although maybe you could do it with CyberChef. I haven't tried. I don't know. It's all command line. Hashcat's there. We spit into output text file and just YOLO it. Now we have password dumping. You remember these guys that I brought up like, I don't know, 40 minutes ago? They're back because we're gonna talk about dumping passwords now. It's like the 10th time I'm gonna say this today. LDAP's a bunch of objects, right? What's a really nice way to get access to another object is if you just have its credential, right? So that's what we're gonna be trying to do. We're gonna dump a bunch of creds and try to get access to different accounts and control more of the domain. So first, LSAS. This one's probably the least important out of all of them in terms of in our particular use case, because LSAS means you're dumping its memory. So you're reading LSAS's process memory and you're just grabbing the parsing and grabbing the credentials out. This is a lot harder to do in practice now because of antivirus and other multiple things. And honestly, because like you have to hop on the machine, you have to get administrative access on that machine, then you use the tool to dump LSS, and you move to the next machine. It just takes a while, and it's probably the hardest, or just the slowest attack to do out of all of them. So there's a tool called Mimikatz, very well known. You could just dump LSS with it using a few commands. Then we have dumping SAM. SAM on the like LSS can be dumped remotely in the not too complicated way. SAM is stored in the registry. The registry on Windows is accessible remotely through SMB or RPC. I feel like it's both. So if you have network level access to a target and you have command execute, or if you have network level access and administrative access to a machine, don't necessarily need command execution unless you want to dump SAM on the host itself. But as long as you're admin and you can hit the machine, you can dump SAM and get local account credentials, right? So this administrator account that this guy just dumped over here, right? Or I guess it's French. But the French administrator this guy has, it won't work on the domain because it's an account that's local to wherever this is. If this was dumping SAM on the domain controller, I do think it would end up working for a domain because I don't think there's local account on the domain controller at all. But there's nothing stopping you from spraying the credential that you get from here. Now, remember what I was talking about earlier? NTLM, LM, NT, right? Makes sense. Because why not? We'll go into more of what you can actually do with this hash in a bit. But let's see. Then we have dumping LSA. Dumping LSA Uh, you guys can see like my full screen, like the random zoom stuff isn't in the way, right? Like it's in the way for me, but I was just assuming y'all can see. Oh, okay. Awesome. Yeah. Okay, cool. So dumping LSA, very similar to dumping SAM, just switch your flag and gets dumped over the registry. Same requirements as SAM too, right? And I mean the output looks the same. Notice they're using crackmac exec. That was like the previous version of netexec. Um Random infosec drama happened and it changed names and owners, but it was all open source. Yeah. One of the guys involved was actually a CPTC organizer too. It was kind of funny. But anyways, you get a lot more information here. You get these DCC2 hashes. They are domain cache credentials. So when you log onto a machine, caches your credentials. For some in case of like a rainy day or something like that. Pretty much like very unfeasible to crack. You get some Kerberos keys and the hex of the machine account password. Machine accounts or system do have a password. It's a bunch of random letters and it's huge. So you're generally not gonna uh well, unless you get the password itself through some other means, you're authenticating through them is a little difficult. And while my laptop is dying, give me 1 second, I gotta grab a charger. Holy crap, this hotel sucks, dude. I had to like the outlet right next to my laptop doesn't work. Why is NTLM I don't use? I don't understand the benefit of slapping two mid hashes as opposed to just using a more secure hash. So it's a little weird too. So it's because Windows is has a thing for backwards compatibility, right? So they still support LM the LM is still there in case some systems support or require LM. NT was a continuation that was used between like I think like late 90s till like even now, right? So you'll notice if I go back to the SAM part, the two parts, right? On the left is LM, on the right is NT. This AAD3, that actually means it's an empty LM hash, which means it's not used. The NT hash, or yeah, empty LM hash on the left, they all have an empty LM hash, which means this domain doesn't use LM. But on the right, we see a bunch of random stuff, right? Uh, well, for administrator anyways. The other ones have empty NT hashes, which means they're not they're not active and they don't do anything. But administrator has an actual NT hash. That means it's using NT as the when it authenticates with NTLM authentication, it uses NT. NTLM authentication provides like support for either doing LM or NT. Like the NTLM authentication protocol itself. Uh the whole colon thing isn't necessarily how it's format. It's not like how it's actually stored in the data. It's more so the tool just kind of parses it and sets it to you that way. It makes it convenient for us. The actual colon in the middle is not a part of the hash itself. It's just a sort of formatting convention that all of these tools have been doing. Yeah, I guess yeah, that's like a little bit of I don't know how to describe it, but whatever. Anyways, moving on. Dumping LSA, you get more information and credentials to crack. Uh, when there is a service that's running on a computer, right? Not necessarily a Kerberos service account, but like let's just say a local service, like your printer, and let's just say you decide to make your printer run as a user account, you would have to provide credentials for that user account for that printer service to run. If you dumped LSA, you would see that password in plain text. Very nice. I I do not recall if it's because it doesn't store it encrypted or if it's because it's a reversible sort of encryption. But regardless, LSA is also a useful source of information. Now we have DPAPI or DPOPI, right? Um, Not exactly the same requirements as dumping SAM and LSA. I know I listed it out as it because if you have system access on a machine, you could dump all the DPAPI stuff, just like you would with SAM and LSA. But if you're a normal user or you have normal user credentials and that particular user has things information stored by DPAPI, you could also grab those, but only for that user in particular and not for the everything running on that machine. So you can dump that. And as you can see, schedule tasks that run as a specific account, they have their DPAPI reversible encryption. So you can, well, I mean, I think inherently encryption is reversible if you have the right information. You could decrypt it. So you can decrypt all the you could decrypt schedule task credentials and you can get credentials that you use that you whenever your browser's like, hey, I saved the logon, right? MS Edge, Google Chrome, Firefox does this. I think all I don't know a browser that doesn't. Although actually there was a recent update to Google Chrome. They're switching out DPAPI to my understanding. And then we have this last thing called the ntds.dit. It stands for like new technology directory services data information tree or something like that. It's same requirements as SAM and LSA, except only on the domain controller. When I was talking about domain controllers syncing and replicating information, this is all that information. They basically just like sync up. I wouldn't say they necessarily sync up this file, but at least my understanding is they all have like a copy of this file that gets modified to have the proper information when it needs to when the syncing is happening. You can also, you don't just need to have administrative access to uh the domain controller to perform this. You can also have what's called replication privileges. Replication being the replication privilege being a thing on LDAP, right? Where if you have replication privileges on the domain, you can simply request you can imitate how a domain controller requests to replicate information, and you will read all that information, right? Because everything's an object in LDAP. So if you have the proper attribute and you authenticate as that particular object, you can do what that object does on the domain. In this case, a domain controller can replicate. So what if for whatever reason we have a user account that has the privilege to replicate, right? Well, we authenticate to LDAP as the user account, or not LDAP, but we authenticate to the proper, I believe it's an RPC protocol, uh, inactive on the domain controller as that user, and then we say, hey, I'd like to read all of your data, and it's like, well, you have the privilege, so okay, and that's what to do. This attack's called like a DC sync attack. If yeah, it doesn't look like there was a label there. So now I'm going to go ahead and demo all of these real quick. I know I want to leave some time for the lab, and I think, yeah, I mean, we're almost done, so you guys will have a chance to go through all this. But oh man, it's really rough to type now. My laptop's all the way backed up, but we're gonna start dumping all the creds that we can. So I don't know if Ichiban is an admin anywhere, right? Well, I technically do because I made this lab, but there's nothing stopping you from just authenticating to SMB because SAM and LSA dumpable through registry, and you just see, well, you could just try to dump SAM. If you can't, you can't, and if you can, you can, right? If you really want to check though, you could just authenticate to SMB with a particular user. And anyone want to take a guess what pwned means in this case? I guess not necessarily means, but indicates owned. I wouldn't say it means owned. It's more like a funny flavor text that they put in. It basically means, and I think you can actually customize it too, but it basically means you have administrative access to this machine. Through authenticating the SMB, it determines, oh, you're admin on this machine. And remember what I said earlier, if you're admin, you can dump SAM, you can dump LSA, you can dump DP API, do all that fun stuff. We're not going to dump LSAS because I don't want to get a shell, download Mimikatz, and do that. It's too much work. So here's my SAM hashes. I'm going to zoom out a bit just so it's all in one line. SAM hashes, empty LM hash on the left. So that means we're not using LM. And it looks like we have empty NT hashes on the right, which means these local accounts might not even be used at all. So, okay, that's it. I don't know what I always see this WDAG utility account. Don't really know what it is and haven't even ever seen it do anything. I need to move this out of my way. Could dump LSA. We could see we have DCC2 hashes, which means administrator and this Curio account logged in at some point in time, but these are usually tough to crack, and I'm lazy, so I'm gonna think about that later. We have credentials for the machine account, so if we wanted to try to authenticate with a machine account, we could try, but that's not going to give us too much of an advantage unless we found one in Bloodhunt already. And then let's see. Then we could do what do you call it? DP API. I just realized I forgot to show Bloodhound enumeration. So we should probably do that in a bit. So we have this Kiryu Cosma account credential through schedule task through DP API. I have no idea what Kiryu can do though. So we should run Bloodhound. Bloodhound, you can actually run it through netexec too, because they were just like, hey, let's just get every single Python tool to attack Active Directory and try to put it in one. So that's what they did. I'm gonna do C. All this means collection methods. All Bloodhound has different collection methods. Because it's not just used as a pen test tool. Some people try to do it as like a red team tool. Doesn't work all too well. But the idea is like you can change how your queries work, and certain queries, well, they query for different information, but there's a chance that depending on what you're doing, you might accidentally go out of scope of your engagement with your Bloodhound query. So that's also why they let you have a little more fine-tuned control over that. They said it was in root, the netexec file, logs, and the Bloodhound zip. Funny thing with Bloodhounds, you could just feed it a zip file and it can just unpack the data and give you all that good stuff. Now, when we go into Bloodhound, we can see, wow, we could do a bunch of quick analysis stuff, such as finding shortest paths to something, to high value targets. This one usually works in a small lab. If this looks a little weird if you haven't seen it before, it looks a lot worse if you run it on an actual environment because there's a billion things. So we could see some accounts have some things. But what I'm interested is this Kiryu guy, because we just got his credential. And it says, well, you click on him. And then it says if we scroll all the way down, right, we can check at his outbound object control. He has a bit of outbound object control. Well, there's first degree and transitive, which means what he owns. Well, one, he already has DC sync. That's interesting. And the other thing is he's a domain admin, which means this is effectively like the admins group on your computer, but applied to the domain. I was like, wow, we just dumped his creds and there was a schedule task running as domain admin. Honestly, not the weirdest thing. Somehow these things happen. Uh, there's been even like Kerberos capable accounts that are like have admin access. But anyways, now we can, since he's a domain admin, we can also do the DC sync with him. So if we do SMB on the domain controller, we do what is it? Can't type. Pass the NTDS flag. So it's gonna cry and say, oh, you might crash the computer. And it's like, no, you won't. Except one time it did happen on a client, and that was not good. But we don't talk about that. So here are all the NTLM hashes for the domain. These are all the accounts on the domain. Here's all the NTLM hashes, even the machine accounts, right? We see LM on the left blank because there's LM's not used, and NT on the right. Anyone want to guess what's our next step here? He was like, okay, we dumped all their hashes, right? And I know I did this from like a domain admin's perspective, so like this doesn't really give me anything extra, but sometimes it's possible to dump NTDS without being a domain admin, which makes things really interesting. Uh, this was just for the sake of an example. But with all these NT hashes, what do you think we do with them? Crack'em is good, right? It'd be cool to get plain text passwords, but fortunately, Windows decided, hey, we are really nice people. You don't need to crack them. NT hashes in particular, right? And like, okay, so like if I don't crack them, then like what the hell do I do with them, right? There's some called pass the hash where you say, I'm going to authenticate with a hash instead of a password, and it works. Great cryptography. I'm no crypto person, but feel like feel like that's not how it should work. So now let's try to figure out why this is the case, right? So if we think back to NTLM authentication, like I brought up earlier, right? You send your authentication request, you say, hey, I'm what was it? Uh One, let's say I'm administrator, right? We dumped a hash. I'm administrator. They're like, okay, here's a challenge, right? Here's like a set of data. I need you to encrypt this data with, earlier I said password. That was inaccurate. You need to encrypt this data with a hash of that password, right? Because if you have the hash of the password, it means you had the password because you were able to hash the password, right? So using the hashed password and the NT hash, right? You then use that to perform some sort of mathematical operation on the challenge and send it back to the host. The host is like, well, it looks right to me. So this is where you notice it's like this is where the bit of the funny comes in, because it's this third step over here, right? That the response when you encrypt that random data with the NT hash, there's like no salting or anything going on. You just need the hash. So you kind of look at it, it's like, wait, you you encrypt it with the hashed password, not like the password, not like anything else. You just use the hash. I was like, wait, why do we need a password then, right? So that's exactly the case. Why do we need a password? I don't know. Luckily, our Python tooling supports this. If you try to log into your computer and you just like put the hash into like the login form, it's not going to work. You need to interact with the protocol a little more directly. So let's just say I want this Diago guy for whatever, right? Like I don't have his password, but I got this thing, right? That I didn't end up copying properly. That's a bro moment. We're gonna use the H flag instead. Yeah, man, we didn't need passwords anyway, I guess. Mm. Yeah, so Uh, thing with Active Directory, and NT hashes are they're awesome. We love them. They make our lives easier. Uh, some people you can even authenticate to Kerberos with an NT hash and get a Kerberos ticket if they weren't letting you do this type of authentication for over like other protocols, right? It's like, oh yeah. It's like, yeah, you could crack them, but what if we did something else that was funnier and a lot easier, right? You can't do this on Linux. You get a hash on Linux and you start crying because it's blowfish and it says Hashcat says it's gonna take 48 years to crack, and you're like, oh man, it's not fun. You get a hash here and you're like, oh, yay. Well, it has to be an NT hash. You can't pass the Kerberos hash, you can't pass the ASRep roast hash, can't pass DCC2. But you can pass this one. And this one's pretty common. So that honestly, I finished a bit on time. I was hoping to leave you guys with like half an hour to do the homework. But yeah, I'm not sure if you guys already cloned this already. If you cloned it any time before like 5 minutes before I started presenting, then you're gonna need to reclone it because there were some, well, you might not need to reclone it. I just had to end up fixing some things and making some quality of life stuff for you guys. But yeah. So we got the CPTC week 5 template, right? That I've been working on and off. The goal for the homework is gonna be perform 4 attacks. If you don't know something you're doing constitutes as an attack, feel free to reach out to me. I'll be like, yeah, that's an attack, or that's not really an attack. That's just whatever, right? A lot of things I would consider are attacks, right? There's some examples that we covered, right? Credential dumping, Kerberos, past the hash, SMB, I didn't talk about SMB command execution or ACL abuse. Well, DC syncs a bit like ACL abuse. Uh, there are extra vulnerabilities that you can do that I have not that we didn't cover. If you can find them and we'll we'll reward some appropriate points depending, like, was it a difficult one? Because I implemented some pretty interesting ones and there's some stuff that are just like weak defaults. Are like, yeah, okay, it's whatever, right? So depending on the extra vulnerabilities that you find, you can get more points. On top of each attack, though, I don't want you to just do them. I want you to make sure that you can actually explain what's going on. I want you to explain, why does pass the hash work? Why does a Kerberos work? Why does the specific ACL you abuse actually do the thing? Like, what is a generic all? What is a DC sync? You probably don't know because I didn't explain it, but I have resources in the next slide. This stuff is really well documented by at this point in time. Uh, and when you're explaining the theory, I want you to include 2 other important bits of information. Like I was showing in the slides, what do you need to perform the attack, right? Like, you could say, okay, this is how a Kerberos works. I'm like, cool. Well, how do I, like, what do I need to do it, right? So make sure you include the prerequisites that like I listed out, and include why would someone want to do this attack? Or what does a Kerberos give you, right? Why do an attack if it doesn't give you anything? Or just you want to know, I want to see you guys know like why we do these things and how they work, because it's really important. A lot of Active Directory testers, they're a bit skitty in a sense, where it's like, we run a bunch of tools, we don't know what they did, we don't know why they worked, but now I'm domain admin and whatever. It's like, cool, but that doesn't really prove to me that you understand why Active Directory works. It proves to me that you memorize how to send a few command line stuff and YOLO things. So I want to make sure that you guys understand like what's going on here. Now, every attack you run, I want screenshot the results, screenshot the command too, or at least copy and paste the command. Sometimes they have big outputs, so I know you can't really fit them in one nice looking screenshot. Make sure the screenshot is like reasonably formatted. I don't want to get like a super wide hash, or I have to like, you know, zoom all the way in. It's like an annoying screenshot. Maybe instead of a screenshot, if it doesn't work, you could try a copy and paste and make like a text block, right? Uh, Explaining what each command does sort of ties into explaining the theory, right? You just have your command, you say this is how the attack works, this is the information that the prerequisite information for the attack that is provided by the command that the tool processes, right? Like what, like just explaining what do you call it, this flag here, right? I'm authenticating to SMB on the network with the Diago account, passing the hash, right? That's something like that. Uh, the spoiler alert, there are some ADCS things, Active Directory Certificate Services, out of scope for this presentation, but super relevant right now in Active Directory testing. It's like anywhere you see it, there's some ADCS, and like 80% of the time it's involved with escalation to domain admin, right? And lab's been a bit finicky. You may have to reboot the CA and the domain controller if you want to get those working. There, here's your target scope. It's a 24. Last year, I think I put a 16 on accident. Not making that mistake again. I was like, oh, there can't be that many more hosts on a 16 than a 24. Subnetting. There's a creds for Neo4j, so you can open up Bloodhound and log in. You don't need to set Neo4j yourself. And this is taking position of an assumed breach, right? So I've already provided you credentials and you have network access, so you could just go crazy. You don't need to focus on any of the initial access stuff. You could try if you want. I won't stop you. Like I said, with the, or like I was mentioning with the initial slides up here, there are so many things you could do with Active Directory, and we covered, even within the stuff that we covered, it was like a very, we scratched the surface. And this lab still scratches the surface, but a little, it's like a better scratch, like, you know, scratch harder. Anyways, here's some resources on the next slide. Got everything from like some command execution stuff, ADCS, whatever. It's not just in these links, but on the sites that these things link to are just really useful sites. Hacker recipes, use it all the time. iRed team, all the time, right? NetExec documentation, it's pretty good, pretty solid. There's definitely not a blog post by my roommate. It's a good blog post though. And with that being said, are there any questions before I give all the time back to you guys? Oh, okay. Thanks. Happy you guys enjoyed the presentation. It's Active Directory is always a fun one. People think it's like, oh, Active Directory Windows hard, and it's like, actually no, it's really easy and it's stupid, and Linux is hard. Uh, no, no, the network testing is just like goofy as hell. My my Discord, for if anyone wants to send me questions, it's Nigerald. It's this thing. That's not my icon. That's my Twitter icon. If you find my Twitter bonus points, no, not really. Don't count me on that. Mung won't like that. Uh, but yeah, Active Directory, very fun. I think it's on the easy end, but there's a lot you can do. It's really fun to learn, and it's very important for CPTC too. They've historically always had like, or within the past few years, pretty chunky AD environments, and it's where we get a lot of our bit stuff from. Um, there. Oh yeah, and you could expect Active Directory to be on the tryouts, and if it isn't, I'm gonna yell at Mung. That being said, though, you guys could just work on the lab now. Toss me any questions. Take an early lunch, whatever it is that you want to do. Uh, I'm personally really tired because I want to sleep at like 4 a.m. So I might just like kick back for a bit and answer Discord questions on my phone. But yeah. Uh, take care, and I'm assuming y'all signed in anyway, so there's no questions. I'm gonna head out in a bit. All right, looks like there's nothing for me. I'm going to make my exit then, and oh, the sign-in link. It's like here. Um, oh wait, Bill, I think you can like cut the recording, or is that me? How do I do that?